Welcome to your lesson on work and energy. Okay, this is part of unit 6.3 in the additional physics. So first thing, I'd like you to try and answer these questions relating back to our work on space. Okay, so answer these questions and then come back to the video after you've written them down in your notebook. Okay, so really straightforward. Name the planets in order in our solar system in order, starting closest to the sun. Okay, we all are fully aware of this, I'm sure. So it's simply Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay, remember that Pluto is no longer a planet and it is a dwarf planet. Okay, first three stages of star life cycle. Okay, we're looking at the main sequence star. Okay, we start off with a nebula, which is our cloud of gas. Okay, that turns into a protostar. Yeah, when the star starts collapsing under gravity, okay, there's more collisions, it starts heating up. Okay, and then finally it collapses so much that we get fusion of hydrogen taking place and we get a main sequence star. Okay, why do stars move from the red giant stage to the red supergiant stage in the life cycle? Simply put, the main sequence stars used up all the hydrogen. Okay, there's no more hydrogen to fuse. Okay. Oh, that should be a U. There we go. And they go on to fuse helium in the red giant or red supergiant stage. Sorry. What are the final three stages for a star similar to a sun? Okay, so after it's been a main sequence star, it will go on to be a red giant. Following that, once it's fused everything up to iron, so it's formed its iron core, it will collapse, heat up, and become a white dwarf. Okay, and then it will start cooling because there's no generating of heat, and it will slowly become a black dwarf. It's no longer producing any radiation, so it cools down. Okay, we can't see it. What are the end stages for a massive star after a supernova? So we're either going to have a neutron star, there's my T, or a black hole. Okay. What they become depends on their mass. Neutron star is a high mass star. Black hole is a super massive star. Okay. On to our lesson today, work and energy. Okay, so we know that energy is conserved and calculate work done, kinetic energy and potential energy. Okay, so our learning journey today is we're going to be looking at work done and energy. Okay, we're going to calculate kinetic energy. That's energy of something moving, and then we're going to calculate gravitational potential energy. Okay, so something that has height. Okay, we're also going to be calculating work done, but we need to find out about work first. Okay, so work done and energy. When a force moves an object, the force does work on the object. Okay, work is energy. So when we ask about the energy that's used to lift this barbell, for instance, okay, we know the distance. Okay, we know the weight. Okay, so this weightlifter has done work on this bar to move it above his head, okay, or above their head. Okay, we can calculate that. Work done equals force times distance. We need to know the units for this. Okay, we've said work done is energy, so we know that's joules. Okay, force is measured in newtons and distance is measured in meters. Okay, so that's capital J. Okay, for work to be done, there must be a force. And there must be movement against the force. Okay, so you move a distance. All right, we can write that as work done equals force times distance. Okay, and it's the distance moved against the force. Okay, so yeah, if you want these equations, okay, so if we want to find the force, it's work done divided by distance. If you want the distance, it's work done divided by force. There's the triangle if you feel you need to use it. Okay, so let's calculate the work done. Okay, so let's read our success criteria first. I'm going to change pen colour so you can see when I tick these off. Okay, underline or highlight the important information. Okay, so let's have a look through. We know work done equals force times distance. So I'm going to put those in. So we've got 2 meters and 100 newtons. Okay, so force equals 100 newtons. Distance equals 2 meters. Okay. So we've underlined or highlighted, we've listed the important, let's write the equation, we've written the equation. Okay, substitute into the equation, so I'm just going to put equals 100 times 2. Okay. Rearrange and calculate. I don't need to rearrange, I can just calculate, and I know that 2 times 100 is 200. Okay. Finally, I need to use the correct units. It's work done, so we know that is in joules. Okay. Mrs. Saint bench presses 500 newtons. She lifts the weight a distance of 0.8 meters. How much work does she do? Okay, so again, we need to underline or highlight the important information. Okay, we've got a force and we've got a distance. Okay, list the important information. So force and distance. So the force is 500 newtons. The distance is 0.8 meters. Okay, now we need to write the equation. So we got work done equals force times distance. Okay, so that equals 500 times 0.8. Okay, and that gives us 400 joules. Okay, so we've written the equation, substituted, rearranged, calculate, and using the correct units. Okay, the reason that we set these out this way, okay, so if we were marking an exam, we can see you've selected the correct information, you've selected the correct equation, okay, you've substituted them in, you may have made a mistake at this stage, and then you get a different answer, and you get follow-on marks, okay, so it's really important that we do set our work out like here are a couple for you. Make sure you've typed those into your notebook so you've got them set out exactly as they are. There's a to show what we've done. Okay, I'd like you to answer these 2 questions. These are 2 of the questions I'll be marking at the end of your lesson. Okay, so moving on to kinetic energy. So any moving object has kinetic energy, okay? It depends on 2 quantities, okay? The mass and the velocity squared, okay? So doubling the velocity is going to make our kinetic energy increase by a factor of 4, okay? So the velocity is the big factor here, but also increasing the mass is going to make our kinetic energy increase, okay? Simply put, kinetic energy equals a half, it's just a number, okay, times the mass times the velocity squared, okay? Now, if we want to find the speed of an object when we know the kinetic energy, we've got to rearrange it, okay? Simply put, we've got the velocity equals the square root of 2 times the kinetic energy over the mass, okay? I'll show you how to do that in a short while. Let's have a look at our problems, okay? I hope I've left enough space here. Right, a car of mass 1,000 kilograms is travelling at 30 meters per second. What is its kinetic energy? Okay, underline or highlight. Let's underline here. So we've got 1,000 kilograms and 30 meters per second. Okay. List the important information. Okay, so M equals 1,000. V equals 30. Okay. Write the equation. KE equals a half mv squared. Okay, let's substitute into the equation now. Okay, so we get a half, remember that's just a number, times 1,000 times 30 squared, okay? So if you haven't got your calculator, you might need to do 30 times 30. Okay, so that is going to give us 500 times 900. Okay, and 900 is 30 squared. Okay, so 500 times 900 is going to give us 450,000 joules. Okay, remember it is energy, so it is joules. Okay, substitute, rearrange. We didn't need to rearrange, fortunately, and then include the correct units. So, for this next question, you'll need to type that into your booklets. For this next question, okay, we're going to have to rearrange here. Okay. So, I'm going to use a different colour. Again, underline or highlight the important information. So we've got 10 kilograms, okay? And this time we've got joules, we've got energy, okay? So M equals 10, and kinetic energy equals 12,500 joules. Okay. So I've underlined and I have listed the important information. Okay, I'm going to write the equation, but obviously we need to change this in a minute. Okay, so let's substitute into the equation. So we get 12,500 equals a half times 10 times v squared, sorry. Okay, so this is where we need to start paying attention, okay? So how do I get that v squared on its own? So the first thing I'm going to do is times both sides by 2. Okay, so 2 times 12,500 is going to give me 25,000. Okay, so I times both sides by 2, gets rid of my half there, so I get 10 times v squared. The next thing I need to do is divide by 10. So I now have 2,500 equals v squared. Okay, so as you know from your maths lessons, to get rid of the squared here, we need to do the square root of both sides. So squaring v squared is going to give me v. Squaring this, taking the square root of this, well, we need to find out what that is, and I had to use a calculator for that. Okay, so v equals the square root of 2,500. Okay, and fortunately that works out just to be 50 meters per second. Okay, so that is the most difficult type of question they can ask you, and even then, if you're using your math skills, okay, and relying on the success criteria, that problem becomes quite straightforward. Okay, right, so kinetic energy, I've put this as a we do, but I think you'll be able to answer that for yourself. Okay, remember, underline and highlight the important information, list the important information, write out the equation, substitute into the equation, rearrange and calculate, and then include the correct units. Okay, we're looking at kinetic energy, so it's going to be joules. Okay, so pause there, have a go at this question. Okay, so we've got 50 kilograms and the velocity there, so m equals 50, v equals 1.5. Let's put 8 units in. Okay, so kinetic energy equals a half times 50 times 1.5 squared. Okay, so that gives me 25, because a half of 50 is 25, times, and 1.5 squared is 2.25. Remember, you can do that on your calculator just by doing 1.5 times 1.5, all right? Okay, so 25 times 2.25, so because it's 2 times 25, I know it's going to be just above 50, and that gives us 56.25 joules, okay? Again, there's some questions for you to have a go at, okay? The first one is straightforward, exactly the same as the we do. The second two are like the second one on the I do, okay? So have a go at those. Again, I'll be marking these as on your notebook as part of your assignment. Okay, so the final part we're looking at today is gravitational potential energy, or GPE. Okay, as objects increase their height, they gain GPE. Okay, it takes energy to go uphill. All right, you've got to push a ball or carry a ball up to the top of a ramp. Okay, before you can let go of it, you've got to climb a ladder to get up to the top of a slide. So you're using energy. Okay, that energy is then stored at the top, at the highest height. Okay, and the equation that we're going to use is gravitational potential energy equals the mass times gravitational field strength. Okay, on Earth we use 10. Okay, and then multiply that by the change in height. Okay, so it might be something drops from 10 meters down to the ground. Okay, in that case the change in height would be 10 meters. Okay, we can write that as mgh. Okay, gravitational potential energy, GPE equals mgh. Okay, so some problems. Okay, a 60 kilogram woman walks all the way up a hill. The hill has a height of 1,200 meters. How much potential energy has she gained? Okay, be careful in your exams. They might put 1.2 kilometers, and you need to know that a kilometer is 1,000 meters. Okay, so let's underline important information. Okay, there's our two important bits of information. Let's list them. M equals 60 kilograms. H equals 1.2 kilometers, which equals 1,200 meters. Okay, so then we need to write our equation. So GPE, gravitational potential energy, equals mass times gravity times height. Okay, remember gravity equals 10 in this case. Okay, right, so, and that would be newtons per kilogram or meters per second squared. Okay, so let's work this out then. Okay, we've written the equation, let's substitute in. So we're going to get 60 times 10 times 1,200. Okay, all right, so let's work that out. So 60 times 10 is obviously 600. Multiply that by 1,200. I did this on my calculator to make sure I got it right. Okay, and that gives us 720,000 joules. Okay, remember again, we could write 720 kilojoules. Remembering that kilo, the K, means thousand. Okay, substitute, rearrange, includes the correct units. Okay, a skydiver has a mass of 90 kilograms. When dressed in parachuting gear, she jumps out of a plane at a height of 5,000 meters. She opens her parachute at a height of 3,000 meters. How much potential energy does she lose when falling this distance? Right, so I'm going to draw a little picture. Okay, so this is the highest height. There's where the aeroplane is. Okay, I'm going to struggle to draw a little aeroplane here. One of the worst aeroplanes you've ever seen. Okay, she falls from 5,000 meters, okay, to 3,000 meters, where that she opens her parachute. Okay, so let's calculate. We're going to circle those because they're the important bits. Okay, what we need to work out what the distance is that she's changed here. Okay, so 5,000 minus 3,000 gives us our height, which equals 2,000 meters. Okay, so mass equals 90 kilograms. Height equals 2,000 meters. Okay, and then we can just, and gravity equals 10 meters per second squared. Okay, all right, so we go gravitational potential energy equals, let's tick these off, sorry, there we go, there's on our third one, mgh. Okay, so we get 90 times 10 times 2,000. Okay, and we work that out, so we get 900 times 2,000. Okay, and that is going to give us 1,800,000 joules. Okay. All right, so you need to make sure you've got all these I do's and we do's typed into our notebook, and you obviously need to include your working for the you do questions. Okay. Right, so there's another one, and finally there's a challenge question. Okay, so if you follow the success criteria, these challenge questions are not they're not difficult. Okay, it's just thinking about what you need to do and following the methods in the success criteria, using your numeracy skills, and you will be fantastic at answering these. Right, okay. Thank you very much for listening to the video. You can use the video again if you need any support with your questions and your assignment. Okay, so you just need to go back now and complete the questions in your notebook. Right, thank you very much. Have a great day.